Mercury, the closest planet to our Sun and the smallest in the Solar System, is also one of the least understood. Compared to more glamorous planets like Mars, Jupiter, and Saturn, Mercury has received much less attention from scientific study missions. It's slightly larger than Earth's moon, so scientists assumed it was another cold, dead, and dull-cratered world without much to offer to our understanding of the story of planetary formation. But Mercury also has its own secrets, and now scientists using powerful telescopes like James Webb have stumbled upon these secrets. They are seeing something moving that they never saw anywhere else. These revelations could lead to crucial missions to reveal a terrifying truth about our universe. Join us as we shed light on some of Mercury's most enduring mysteries. Mercury is the innermost planet of the Solar System and the 8th in size and mass. Its closeness to the Sun and its smallness make it the most elusive of the planets visible to the unaided eye because its rising or setting is always within about 2 hours of the Sun's. It is never observable when the sky is fully dark. The difficulty in seeing it notwithstanding, Mercury was known at least by Sumerian times some 5,000 years ago. In classical Greece, it was called Apollo when it appeared as a morning star just before sunrise, and Hermes, the Greek equivalent of the Roman god Mercury, when it appeared as an evening star just after sunset. Hermes was the swift messenger of the gods, and the planet's name is thus likely a reference to its rapid motions relative to other objects in the sky. Even in more recent eras, many sky observers passed their entire lifetimes without ever seeing Mercury. It is reputed that Nicolaus Copernicus, whose heliocentric model of the heavens in the 16th century explained why Mercury and Venus always appear in close proximity to the Sun, expressed a deathbed regret that he had never set eyes on the planet Mercury himself. Until the last part of the 20th century, Mercury was one of the least understood planets, and even now the shortage of information about it leaves many basic questions unsettled. Indeed, the length of its day was not determined until the 1960s, and Mercury's nearness to the Sun gave scientists bound to Earth many observational hurdles, which were overcome only by the Messenger probe. Messenger was launched in 2004, flew past the planet twice in 2008 and once in 2009, and settled into orbit in 2011. It mapped the entire surface of Mercury before crashing into the planet in 2015. Mercury's proximity to the Sun has also been exploited to confirm predictions made by relativity theory about the way gravity affects space and time. At first glance, the surface of the planet looks similar to the cratered terrain of the Moon, an impression reinforced by the roughly comparable size of the two bodies. However, Mercury is far denser, having a metallic core that takes up about 61% of its volume, compared with 4% for the Moon and 16% for Earth. Moreover, its surface shows significant differences from lunar terrain, including a lack of the massive dark-colored lava flows known as Maria and the presence of buckles and scarps that suggest Mercury is shrinking. Mercury is an extreme planet in several respects. Because of its nearness to the Sun, its average orbital distance is 58 million kilometers, it has the shortest year, a revolution period of 88 days, and receives the most intense solar radiation of all the planets. With a radius of about 2,440 kilometers, Mercury is the smallest major planet, smaller even than Jupiter's largest moon, Ganymede, or Saturn's largest moon, Titan. In addition, Mercury is unusually dense. Although its mean density is roughly that of Earth's, it has less mass and so is less compressed by its own gravity. When corrected for self-compression, Mercury's density is the highest of any planet. Nearly 2/3 of Mercury's mass is contained in its largely iron core, which extends from the planet's center to a radius of about 2,100 kilometers, or about 85% of the way to its surface. The planet's rocky outer shell, its surface crust, and underlying mantle is only some 300 kilometers thick. As seen from Earth's surface, Mercury hides in dusk and twilight, never getting more than about 28 degrees in angular distance from the Sun. It takes about 116 days for successive elongations, that is, for Mercury to return to the same point relative to the Sun in the morning or evening sky. This is called Mercury's synodic period. Its nearness to the horizon also means that Mercury is always seen through more of Earth's turbulent atmosphere, which blurs the view. Even above the atmosphere, orbiting observatories such as the Hubble Space Telescope are restricted by the high sensitivity of their instruments from pointing as close to the Sun as would be required for observing Mercury. Because Mercury's orbit lies within Earth's, it occasionally passes directly between Earth and the Sun. This event, in which the planet can be observed telescopically or by spacecraft instruments as a small black dot crossing the bright solar disk, is called a transit. Such transits occur about a dozen times in a century. The next transit of Mercury will occur in 2019. Mercury also presents difficulties to study by space probe because the planet is located deep in the Sun's gravity field. A great deal of energy is needed to shape the trajectory of a spacecraft to get it from Earth's orbit to Mercury's in such a way that it can go into orbit around the planet or land on it. The first spacecraft to visit Mercury, Mariner 10, was in orbit around the Sun when it made 3 brief flybys of the planet in 1974 and 1975. In developing subsequent missions to Mercury, such as the U.S. Messenger spacecraft launched in 2004, spaceflight engineers calculated complex routes making use of gravity assists from repeated flybys of Venus and Mercury over the course of several years. In the Messenger mission design, after conducting observations from moderate distances during planetary flybys in 2008 and 2009, the spacecraft entered into an elongated orbit around Mercury for close-up investigations in 2011. In addition, the extreme heat, not only from the Sun but also radiated from Mercury itself, challenged spacecraft designers to keep instruments cool enough to operate. Regardless, as the saying goes, travel broadens the mind. Scientific knowledge about Mercury was greatly increased by Mercury flybys. For instance, a completely unexpected discovery made by Mariner 10 was that Mercury possessed a magnetic field. Planets theoretically generate magnetic fields only if they spin quickly and possess a molten core, but Mercury takes 59 days to rotate and is so small, just roughly 1/3 Earth's size, that its core should have cooled off long ago. An unusual interior could help to explain the differences in Mercury's magnetic field when compared to Earth. Observations from Messenger revealed that the planet's magnetic field is approximately 3 times stronger in its northern hemisphere than in its southern. Scientists suggest that Mercury's iron core may be turning from liquid to solid at the core's outer boundary rather than the inner. In the words of Christopher Russell, a professor at the University of California, Los Angeles, who co-authored that model, it's like a snowstorm in which the snow formed at the top of the cloud, and middle of the cloud, and the bottom of the cloud too. Our study of Mercury's magnetic field indicates iron is snowing throughout this fluid that is powering Mercury's magnetic field. The discovery in 2007 by Earth-based radar observations that Mercury's core may still be molten could help explain its magnetism, though the solar wind may play a role in dampening the planet's magnetic field. Although Mercury's magnetic field is just 1% the strength of Earth's, it is very active. The magnetic field in the solar wind, the charged particles streaming off the Sun, periodically touches upon Mercury's field, creating powerful magnetic tornadoes that channel the fast, hot plasma of the solar wind down to the planet's surface. In addition, Mariner 10's spectral measurements showed that Mercury has an extremely tenuous atmosphere, and that's really surprising. Previously, scientists still believed that a planet as small and as hot as Mercury had no possibility of retaining a significant atmosphere if it ever had one. To be sure, Mercury's surface pressure is less than 1/1,000,000,000th that of Earth. Nevertheless, the traces of atmospheric components that have been detected have provided clues about interesting planetary processes. Mariner 10 found small amounts of atomic helium and even smaller amounts of atomic hydrogen near Mercury's surface. These atoms are mostly derived from the solar wind, the flow of charged particles from the Sun that expands outward through the solar system, and remain near Mercury's surface for very short times, perhaps only hours, before escaping the planet. Mariner also detected atomic oxygen, which along with sodium, potassium, and calcium discovered subsequently in telescopic observations is probably derived from Mercury's surface soils or impacting meteoroids and ejected into the atmosphere either by the impacts or by bombardment of solar wind particles. The atmospheric gases tend to accumulate on Mercury's night side but are dissipated by the brilliant morning sunlight. Many atoms in Mercury's surface rocks and in its tenuous atmosphere become ionized when struck by energetic particles in the solar wind and in Mercury's magnetosphere. Unlike Mariner 10, the Messenger spacecraft had instruments that could measure ions. During Messenger's first flyby of Mercury in 2008, many ions were identified, including those of oxygen, sodium, magnesium, potassium, calcium, and sulfur. In addition, another instrument mapped Mercury's long comet-like tail, which is prominently visible in the spectral emission lines of sodium. Although the measured abundances of sodium and potassium are extremely low, from hundreds to a few tens of thousands of atoms per cubic centimeter near the surface, telescopic spectral instruments are very sensitive to these two elements, and astronomers. Here is the text you requested, without any emissions. Monitoring the extended sodium tail from Earth can detect changes in Mercury's space environment. In addition to the planet's magnetic field and atmosphere, MESSENGER also yielded important data on Mercury's surface chemistry and geology. Before MESSENGER, scientists thought they had a good picture of Mercury's surface, despite only about 45% of it having been photographed by Mariner 10. MESSENGER was able to map nearly the entire surface during its flybys. Mercury's surface geology is very different from that of Mars or the Moon. Mars has a heavily cratered ancient terrain but also a large amount of younger volcanic activity. The Moon has both old heavily cratered areas and younger areas with lava flows. Mercury, however, has no young lava flows. Its surface is much more heavily cratered than Mars but less cratered than the Moon. One of MESSENGER's most important discoveries is evidence that Mercury's crust has contracted significantly over time. This is believed to be the result of the planet cooling and shrinking after its formation. The most prominent surface features on Mercury are long, high ridges, some up to hundreds of kilometers in length, which appear to be the result of the planet's crust buckling as it contracted. These ridges are different from anything seen on Mars or the Moon, suggesting that Mercury's interior has cooled and contracted in a unique way. Another significant discovery made by MESSENGER is the presence of water ice in permanently shadowed craters near Mercury's poles. Despite the planet's proximity to the Sun, these regions are never exposed to sunlight, and temperatures there can drop to below -170 degrees Celsius. Radar observations from Earth first suggested the presence of ice in these craters, but MESSENGER confirmed it. This discovery is particularly intriguing because it suggests that ice may be more common in the solar system than previously thought, even in places where we might not expect it. As we continue to study Mercury, we are likely to uncover even more surprises about this enigmatic planet. Its unique characteristics and the challenges it presents to scientists make it a fascinating subject for future exploration. With upcoming missions and advances in technology, we may soon have a much clearer understanding of Mercury's role in the solar system and its significance in the broader context of planetary science.